Alright, so I'm going to go over a program that I wrote for a lower class, or a class that is, I don't want to say below me, but that is one that I've already taken. And so I saw this on the board. They were doing inputs, I don't really know exactly, regression equations, I guess. And I was like, oh, hey, I could probably write a program for that that would be faster than actually having to do all the different steps you have to do. And so I'm going to quickly try and outline it. What you have to do to actually do it correctly without a program is to go to the list, which I can list all the buttons off, but I'm just going to mess that up. So you can go to the list, add in your values to both list 1 and list 2, then find the regression equation that you're looking for, and then run that, and then input your variables to that equation, and then from there you have to then store your equation to an actual function, and then you have to look at the function and how close it is to the data, and then compare the data to the equation to see which one, or see how close it is. And so that's the whole process you have to do. And so this kind of simplifies 75% of all those steps. And, well, I'm going to try and put it in English and kind of hash over a little bit of the specifics. So what we want to do is first ask for the values of x and y. And so I took the input of x because I don't want to put it as an actual variable in case, the thought process I had was if I can make it so that you don't have to input how many values you actually have. So if you don't want the calculator to have to ask you how many values do you have, because then that's more inputs that you have to actually have. And so the way I have it currently set up is it'll start a loop, and that loop will say, okay, as long as you're giving me numbers, then I'll keep running. And if you give me x, which means if you're done, then I'll stop asking you for numbers, because it means you don't have any more numbers. And that's what this is. And so that's also why I have display done is equal to x. And so when you're done, then you can just put in x as the value of x, and it'll be done. And so that's why this is a string, because you want to be able to put in x instead of a number. And so if you're not done, which is the string 1 is not equal to x, meaning you're still putting in numbers, then you can then ask for y, and then it stores, in a kind of a roundabout way, stores string 1 to a function y of 0, and then it takes y of 0 at element 0, which is because string 1 and y of 0 should be a number instead of like 5x, it should just be 5. And so 5 at 0 will be 5, and 5 at 100 will be 5, and so it doesn't really matter what element you take it at, but I think you have to have some element, and I don't think you can just store it as a function to a variable. I don't think that works. Because this is a value, and this is a value, this is a function. And so you have to have the function and the value to make it evaluate to a value. And then you store x, which, again, kind of roundabout way of doing it. It's probably a faster way. Let's see if you guys can find that. X at list 1, and you have to have an element, like same thing. You have to have an element, or the list, the function, and then you also have to have a place to put it. Because lists you can add things to, functions you can't. But still, they come in pairs, and so you have to, wherever you have a list, you usually have to have a value unless you're calling for specifically a list, and you're storing a list at a matrix, which you can also do. Could get into that. That's some fun chemistry and a little bit of math. So you have list 1, and you want to store it at a place, and so you have the dimension of list 1, and you want to add 1 to the dimension of list 1 because the dimension of list 1 is all of the values at list 1, or of list 1. And you do the same thing for y, and then you add 1 to it because you don't want to delete or add values to places that you don't want them. And then now that we have all of the values, because if string 1 is equal to x and you're done, then it'll skip all of this. So then you take the minimum and maximum of both list 1 and list 2, and you add or subtract 5 from them, so that you can show all of the values of list 1 and list 2 on the screen without having to have one on the very corner or on the very edge. You're like, wait, what's that? I don't know what that is. And so you can see all the values. And that's why you add 5, just take away 5. And then you want to turn off the function because we still have y of 0. You want to turn on plot 1, and that's so that you can actually see the plot that we're talking about. And you want to turn off plots 2 and 3 in case you have them on so that they don't display on the screen. And then we can run the regression equations, and you have to input the lists that you're talking about, or else it will just display if you run this command, it'll display that whatever that screen is, and then it'll ask, oh, what list do you want? And so if you just input whatever list you want, then it doesn't have to ask. And then you can give it an equation, which is I think the third thing down. If you actually run just this command, you can actually input, it'll ask like place to store it or something like that, and you can give it a function. It only works for a function. And so how you get to the functions, I believe, is vars, and then you go 1 over, it'll say function, you hit enter, and then you can go like, it'll give y1 to y0, and you can input whatever it is. And so this way, again, you just have to input it here before it even has to ask. And then this whole thing, in, again, a roundabout way of doing it, there's probably a faster way. What you do is, I'm evaluating which one's closer to the actual data. And so, one of the things I was talking about before was, you want to be able to tell which equation you have is closer to the actual data, which more closely represents the data. And that way you can use that regression equation to represent the data that could be in the future, possibly. And so it compares the quadratic and the linear equations to each other and sees which one is closer, and then it tells you which one is closer. And then finally you can display the graph. So it shows you all of this. And this is text, so it should display the graph, the graphs up here, as well as the answer, or I guess answer, quote unquote, of which one is closer. So that's what I've written. These are some of the concepts and how you can use them. If you guys are doing this, then feel free to copy this down, but please, I cannot stress this enough, learn how to program instead of just learning what to program, because that way you can then program something else that you want to program instead of having to just program what other people have already programmed. Have a good day and good luck. If you have any questions, please feel free to ask them. And don't forget you have those online sources that I talked about in one of the earlier videos. Thank you.